Morning everyone. Yeah, very good morning. Shall we begin? In the last class, that is in the Friday's class, we have finished with the ER models as well as their diagrams as well as their example. Everything we have finished with the ER model. Now, my question is to Larry. First of all, you have any doubts regarding the ER model? Any doubts, anyone? Any clarification that you want to take? Okay. So my question is, what is ER model first of all? That's fine. It's an entity relationship model. That's the full form. I'm talking about what is ER model, why it is used. Okay, to show the logic, show the relationship between the various entities, we use OER model, right? Now, what are the various benefits that is, yes, that can be provided or that is provided by the ER models? Yes, it can be used with the attributes, it can be used with the issues that are not precise to the relationship, that are not precise to the entities. That is one, yeah, that is one of the issues. Listen, that is one of the issues that we are going to consider or that we are going to take in the today's class only. I'm talking about what are the advantages of ER model. First, remove the duplication, right? Second, provides a backup mechanism, right? User friendly, very good. This is the main point, that this provides a user friendliness. Why? Because everything is represented by the diagrams. This is very much user friendly for the users. Now let's take about the next topic, that is the ER design issues. When we design the ER model, what are the various issues that we cannot neglect? So the notions of an entity set and the relationship sets are not precise, and it is also possible to define a set of the entities and the relationship among them in a number of different ways. That is, examine various issues in the design of a ER database design. So now let's start with first one, that is use of entity sets versus attributes. Why we are using the entity, why we are using the attribute, why we are using the oval shape or the rectangle shape. So first is use of the entity set versus the attribute. So consider the entity set instructor with the additional attribute that may be a phone number. That can be easily be argued that a phone is an entity in its own right with the attributes phone number and the location. Whatever the location, whatever the phone number, whatever the office or the home where the phone is located out, with the mobile number, cell phone, perhaps represented by the value of the mobile. So if we take this point of view that is represented by the phone, that is represented, we do not add the attribute phone number to the instructor. Rather, we create a phone entity sets with the attributes phone number, that may be a phone number and the location. A relationship set, that is a instructor phone, denoting the association between the instructors and the phones where you are liking of that they have. But then is the main difference between two definitions. Why we are using two definitions, that is either treating the home as an attribute phone number that implies that instructor have precisely one phone each, and treating a phone as an entity phone permits instructor to have several phone numbers that may be including the zeros, that may includes the phone number, that may include each and every one, that could instead easily define phone number as an multi-valued output. Now let's take another example, that is the one of the alternative that is used over here. So when we use the phone number instructor that treating the one phone number each, that is treating the phone number as one of the entity, that implies that an instructor have precisely one phone number each. Now treating a phone as a phone number or as an entity phone permits, allows or also allows the instructor to have several phone numbers that is associated with them. However, we could instead define phone number as a multi-valued attribute to allow multi-valued or multiple phone numbers per instructor. So we can also use multi-valued attributes That is, multiple parts are used with the phone number. The main difference then is treating a phone number as an entity, better models as a situation where one may put to keep extra information, extra data that may be required about a phone, such as its location or the type, mobile, IP, or the plain phone, old phone. Or all who shares instructor phone, ID, name, salary, then instructor phone number, location. So there's the ID, name, salary, phone number. So this is the alternative for adding the phone to the instructor entity set. Now, when we treat the phone as an entity, that is more general as treating it as an attribute. Whatever the attribute we are taking out, that is appropriate when the generality or cardinality may be the attribute. And in contrast to this, it may also not to be appropriate to treat the attribute name as an entity, and it is very difficult to argue that a name is an entity in its right context. Therefore, it is appropriate to have a name as an attribute of the instructor entity set. Now, two natural questions arises. What constitutes an attribute? What constitutes an entity set? That means, what are the various parts of an attribute? What are the various parts of an entity set? So unfortunately, they are not simple answer because there is a difference that lies depends on the structure of the real world entities being modeled. For example, when we talk about the hospital management system or the hotel management system that we have discussed in the last class, so that there is a difference between the attribute, there is a difference between the entity set for that scenario based. That may be hospital, that may be hotel management. But a common mistake that is used to use the primary key of an entity set as an attribute of another entity set. So instead of using a relationship, so we are using the primary key as an attribute of another entity set instead of using a relationship. So we have to maintain a relationship between these two entities. For example, it is incorrect to model the ID of a student as an attribute of an instructor, even though if each instructor advises only one student. So there's a relationship advisor. That is a correct way to represent the connection between the. So yes, very good. Mhm. Yeah, advisor is one of the correct way. That means instructor or student. Instructor advises to the student. That is not gaining the or giving the knowledge or teaches the students. No, advisor is the main relationship between the student and the instructor, since it makes their connection explicit rather than implicit via an attribute. And another mistake that people sometimes do is to designate the primary key of the related entity set as an attribute of the relationship. So it takes out the attribute of the relationship. For example, when I talk about the ID, the primary key attribute of student, and the ID primary key of the instructor, that should not appear as an attributes of the relationship advisor. That is not a part of that relationship. This should not be done since the primary key attributes are already implicit in the relationship. That is already done with the relationship. So this is entity set versus the relationship set. Sorry, entity set versus the attribute. Now next is entity set versus the relationship set. What is the relationship? What is the connection? What is the main issue that lies between the entity set and the relationship set? Not always clear whether an object is an instance or whether an object is better expressed by an entity set or a relationship set. So we use the takes relationship set to model the condition situation where a student takes a course, where a student takes a section of a course, and the alternative is to imagine that there is a course registration record for each course that each student takes. So every student takes each code that a student takes. Then we have an entity set to represent the course registration record. Now let us call that entity set registration. So each registration entity is related to exactly one student and to exactly one section. So we have two relationship set, one to relate the course registration records to student and one to relate the course registration record. So one is the course registration record to the sections, one is to the student. So this is the relationship between the section and the student, with the takes relationship set replaced by one entity set and two relationship sets. There is the registration, that is the entity set representing the course registration records. Then section registration relationship set is relating the registration and the course. Student registration relationship set relating the registration and the student. Note that we use a double line to indicate the total participation by the registration entities. This is the section regarding, this is the student regarding, registration, section, student. So that is section regarding, one is the student regarding and relationship. Section regarding have a section, that have a section ID, that have a semester, that have a year. In the same way, student regarding have a student, that have a ID, that have a name, that have a total credit. So both the approaches accurately represent the university information, but the use of text is more impact and probably more preferable. So we mostly prefer the text relationship that is very compact and easy to understand, we can say. However, if the registrar office associates other information with the course registration records, it might be best to take it an entity or its own right. Now, one possible guideline in determining whether to use an entity set or a relationship set is to designate a relationship set to describe an action. What is a relationship set? That describes an action that occurs between two entities or between different entities. This approach can also be useful in deciding whether certain attributes may be more appropriate expressed as relationship, or whether these relationships are expressed with the student, with the section, or whether these relationships are easily built or not. Now, third one issue is that binary versus an array. That means we either use two numbers, that is 0 and the 1 binary, or either we can use an array relationship sets. So relationships in database are also binary or often binary. Generally, it is binary. Some relationship that appears to be non-binary that actually be expressed by several binary bits, binary relationship. For example, one could create a ternary relationship, that is a parent relating to a child to his parent, mother, or father. Such relationship should be maintained with a two binary relationship only, that is the father and the mother. Now, if I'm talking about the gender, that may be either male or female. So again, there are the two relationships between these, or there are two entities in this. One is a male, one is a female. In the same way, in this, there is a relationship that could be expressed with the two binary relationship, mother and the father, that provides us a record of the child's mother, even if we are not aware of the father's entity. So there's the null value that could also be required if a ternary relationship parent is used. And using the binary relationship set is also preferable in this case. And in fact, it is always possible to replace our non-binary relationship set by a number of the distinct binary relationship set. And for simplicity, consider the binary relationship or ternary n equals to 3 relationship set R relating the entity sets A, B, and C. So we replace the relationship set R by entity set E that creates three relationship set that may be a RA, the relationship between the E and the A, RB, relationship between the E and the B, RC, relationship between E and the C. So this is ternary relationship, but this is the three binary relationship. So this is the ternary, this is the binary. And this there are the two relation, binary A and D, binary A and D, B and D, binary C and D. In the same way, there's the relationship A, B, and C. So if the relationship set R had many attributes, then these are assigned to any binary set. These are assigned to entity set E further. So there is a special identifying attribute that is created for the E that must be perceivable, or that must be possible to differentiate different entity sets that is used in one of the entity on its attribute values. And for each relationship as a relationship R, we create a new entity EI in the entity set E. Therefore, then each of the three new binary or relationship set, we could insert a relationship that is EI AI in RA, EI BI in RB, EI CI in RC. So we can also generalize this process in a straightforward manner to an array relationship set. Therefore, conceptually, we can restrict the ER model to include only binary relationship set. However, this restriction is not always desirable. So what are the various restrictions that is always desirable or that is used over here? So we can generalize this process in a straightforward manner that is used. So first point is an identifying attribute may have been created for the entity set created to represent the relationship set. What are the relationship set that is represented with identifying attributes? This attribute along with the extra relationship set required increases the complexity of the design and overall storage requirement. What are the storage requirement? What are the attribute that is compensate that is used with the relationship set? And there's an error relationship set that shows more clearly that several entities participate in a single relationship. And there may not be a way to translate constraints on the ternary relationship into constraints on the binary relationship. So for example, consider a constraint that says that R is many to one from AB to or AB to C. That is, each pair of entities from A and B is associated with at most one entity set. So this constraint cannot be expressed by using cardinality constraint on the relationship set RA, RB, and RC. Now consider the relationship set project guide that relate the instructor, student, and the project. So we cannot directly split project guide into binary relationship between the instructor and the project and instructor and the student. If we did so, we could be able to record that instructor cards work onto the projects A and B with the student Shankar and the Zhang. However, we could not be able to record that cats work on a project A with the student Shankar and works on project Yes, with the student Jang, but does not work on a project A with Zhang or on the project B with the Shankar. So this is the relationship that shows there's a binary relationship by creating a new set as I described above. Now the next part is placement of our relationship attributes. So cardinality ratio of a relationship can also affect the placement of a relationship attribute. Therefore, whenever we are using the attributes of one-to-one or one-to-many, that can be associated, that can be settled with one of the participating entity sets rather than with a relationship set. For example, for instance, let us specify that advisor is a one-to-many relationship set. So that one instructor may advise several students, but each student will be advised by only a single instructor. In this case, there's a relationship, there's a placement of the attribute date, which specified when the instructor becomes the advisor of the student. Now, since each student entity participates in a relationship with at most one instance of an instructor, making it the attribute destination having the meaning that could be expressed with the date, or that could be placing the date with the advisor relationship set. This will be used for one-to-one relationship set, and on the other hand, the relationship attribute can be associated with either one of the participating entities. The design process or design decision of where to place descriptive attributes in each case or in such cases as a relationship or entity attribute that should reflect the characteristics of the enterprises being modeled. Whatever the model he is using, whatever the model that they are using, so that will be modeled with the entity relationship that will be modeled with the relationship constraints. And the choice of attribute placement is more clear-cut from many-to-many relationship set. So returning to the example, let us perhaps using the realistic case that advisor is many-to-many relationship, that set expresses that an instructor may advise one or more student and the student may be advised by one or more instructors. So this is the way to express the date on which a specific instructor becomes the advisor of a student or specific student. That in this case, the date may be used as an attribute of an advisor relationship set rather than either of the participating entities. And if date were an attribute, That may not entity, that may be attribute. So in this case, for example, we cannot determine which instructor becomes the advisor of the particular on that particular date. So when an attribute is determined, so this is determined with the attributes instructor, that is will determine with the entity set with the relationship, that is many-to-many relationship, set advisor that depicts the placement of the date as a relationship attribute, again to keeping the attributes of two entity sets. Next is extended year features. Now let's talk about the extended year features. What are the various extended year features that could often or that could mostly provide the database features? Some aspects may be aptly expressed by the certain extensions to the basic year models. In this section, we discuss the extended year model of the specialization, aggregation, generalization with the lower level entity set with the inheritance with the aggregation. Now let's start with the first one, that is specialization. So whenever we divide the entity set may includes, or whenever we divide the entity set, that may also include subgrouping of entity that is distinct in some way from other entities. For example, a subset of entities within an entity set may have attributes that are not shared by all the entities. So that is not shared by the entities, that are not expressed by the entities. But this ER model provides a means for representing these distinctive entity grouping. So as an example, the entity set person may be further classified as one of the following. One is employee, one is a student. Each of these person types is described by the set of the attributes that includes all the attributes of entity set person plus possibly additional attributes. For example, employee entity or employee entities may be described further by the attribute salary, whereas a student entity may be described, may be used with the entity set that may be further used by the attribute total credit. So process of designated the subgrouping within entity set, that means process of dividing subgrouping within entity set, that is known as a specialization. And specialization of the person allows us to differentiate among the person entities according to whether they correspond to the entities. They correspond to the employees or the student. In general, a person could be employee, a student, or both or neither. So as another example, suppose the university divides the student into two categories, graduate and the undergraduate. Graduate have an office assigned to them, undergraduate are assigned to the residential college. So these will be used with the student plus additional attributes. So the university would create two specialization of the student, namely the graduate and the undergraduate. And as we saw earlier, the student entities are described by the entities ID, name, address, and total credit. So that will be used with the attribute of the student as well as the additional attributes of his number. In the same way, when you talk about the undergraduate, that we have attributes student, that have attribute residential college. So we have specialization repeatedly to define a design. And for example, university employee may be further classified as one of the following: instructor and the secretary. This will include all the attributes of the entity set employee plus additional attributes. For example, these entities may be described further by the week or by the attribute rank, while secretary entities are described by the attribute hours per week. In such case, there is a secretary for between the secretary and the employee entity sets, which identifies the employee who are associated by a secretary. That can be defined with a specialization that can be based on a person, that is temporary employee, permanent employee, resulting in the entity set. And when more than one specialization is forming an entity set, so there is a particular entity that may also belong to the multiple specialization. For example, a given employee may be a temporary employee who is secretary. So this shows a specialization that is depicted by the hollow arrowhead pointing from the specialized entity set. So the formal case, that is a multiple sets permitted, is known as the overlapping specialization, while the later case is known as the disjoint specialization. So one is a overlapping specialization, one is a disjoint specialization. That is based on the multiple specialized entity sets, or if it belongs to the at most one specialized entity set. And for a disjoint specialization, that is used with the instructor and the secretary. So there's a single arrow will be used, and that also refers to a superclass subclass relationship. There is a person, ID, name, address, employee salary, student total credits, instructor rank, secretary hours per week. And the next one is the generalization. So the refinement from an initial entity set into the successive levels of the entity subgroupings also represents a top-down design approach in which distinctions are made explicit. So this design process may proceed in a bottom-up manner, that may be in a bottom-up, that means from bottom it starts, then go upward, 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 in which multiple entity sets are synthesized into higher-level entity sets on the basis of the common features. That common features are first identified with the instructor entity set with attributes instructor ID, instructor name, instructor salary, and instructor rank. In the same way, secretary entity set with attributes secretary ID, name, secretary salary, and the hours per week. So that is known as a generalization, in which there exists a relationship between the high level entity sets with the entity sets of the low level. So to create a generalization, the attributes must be given to a common name and represented with the higher level entity person. So we can also use attribute names, ID, name, address. So higher and the low level entities also designated by the term superclass and the subclass. The person entity set is a superclass of the employee student. So the generalization is a simple inversion of the specialization that is used in combination in the course of designing the ER process. That may be used with the specialization, that may be used with the generalization. So specialization stems from a single entity set that emphasizes differences among the entity within the set by creating the distinct low-level entity sets. There's a generalization that proceeds from the recognition that an entity of the or the number of the entity sets also share some common features in the same relationship sets. And on the basis of their commonalities, generalization also used with the entity set into the single high-level